Welcome everyone to Digital Learning by the Department of Collegiate Education. I am Manjunath Sevi, working as Assistant Professor at Government First Grade College, CSpura. In today's session, let us try to understand the theoretical aspects of what is time reversal test and factor reversal test in session number 25. And in the next session, that is session number 26, let us solve problems on Fischer's ideal index number and how to find out whether it satisfies the time reversal test and factor reversal test. All these are a part of chapter number 3, index numbers, in the subject quantitative analysis 2. This is session 25 of the chapter index numbers. Now here, since we have seen several index numbers like simple aggregative index number, simple average of price relatives, weighted index number, weighted average of price relatives, and further Lasper's index number, Pasch's index number, Marshall-Edgeworth's index number, Fischer's index number, and the list goes on. So out of this, it becomes difficult to decide as to which index number is actually good. So in order to answer this question, we need to find out which index number answers these particular questions. So there's something called as test of adequacy of index numbers. There are different tests like unit test, time reversal test, factor reversal test, etc. So out of these different tests, we will mainly focus on number 1, time reversal test, and second, factor reversal test. As I said, since there are several formulas which have been suggested for the construction of index numbers, the question arises as to which method of index number is the most suitable in a given situation. These are some of the tests to choose an appropriate index. Out of that, the first test is the unit test. Unit test states that an ideal index number should be independent of the units in which the prices or quantities of different commodities are quoted. Only simple aggregative method satisfies this particular test. Coming to the second test, which is time reversal test. Time reversal test is proposed by Professor Fischer. It is a test to determine whether a given formula for calculating the index numbers will work both ways. It's important whether it works in both ways in time, that is either forward or backward. According to Professor Fischer, the formula for calculating an index number should be such that it gives the same ratio between one point of time and the other, no matter which of the two times is taken as the base. Which means to say that even if the base is changed from current year to base year and base year to current year, the ratio should be the same. So considering Fischer's formula states P01 is equal to square root of sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1. So according to this Fischer's formula, changing the time from 0 to 1, that is from base year to the current year, and from current year to the base year, we get sigma P01 will now be 0 becomes 1, 1 becomes 0. So P01 will become P10, which is equal to square root of sigma P1 Q0. 1 will be interchanged to 0 and 0 will be interchanged to 1. Therefore, this will become sigma P0 Q1 divided by, this is sigma P0 Q0, this will become sigma P1 Q1 into sigma P1 Q1, 1 will be changed to 0. Therefore, sigma P0 Q0 divided by sigma P0 Q1 will become sigma P1 Q0. So when we multiply both these, sigma P0 1 into sigma P10, that is multiplying 1 and 2. P0 1 into P10 is equal to square root of sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1. This entire portion represents P0 1 and P10 formula into sigma P0 Q1 into sigma P1 Q1 into sigma P0 Q0 divided by sigma P1 Q0 And when we check here, everything gets cancelled. It is to be noted here that everything gets cancelled. How? P naught Q naught in the numerator, P naught Q naught in the denominator. Sigma P naught Q1 in the numerator, sigma P naught Q1 in the denominator gets cancelled. Sigma P1 Q1 in the numerator and sigma P1 Q1 in the denominator gets cancelled. And finally sigma P1 Q naught gets cancelled both in the numerator as well as the denominator. And finally what remains is only 1 remains as the numerator and the denominator. Therefore P01 into P10 is equal to square root of 1. Finally P01 into P010 is equal to 1. Since P01 into P10 is equal to 0, we can state that Fischer's ideal index number satisfies the time reversal test. So according to the time reversal test, P01 into P10 is equal to 1. This is called as time reversal test. Coming to the next one, which is factor reversal test. Factor reversal test says that the product of a price index and the quantity index should be equal to the value index. In the words of Fischer, just as each formula should permit the interchange of the two times, that is base year into current year and current year into base year, without giving inconsistent results, similarly it should permit interchanging the prices and quantities without giving inconsistent results, which means the two results multiplied together should give the true value ratio. The test says that the change in price multiplied with change in quantity should be equal to the total change in value. I repeat once again, factor reversal test states that the change in price multiplied by change in quantity should be equal to the total change in value. Therefore, factor reversal test is satisfied by Fischer's ideal index. P01 is equal to sigma P1 Q0 divided by sigma P1 naught Q0 into sigma P1 Q1 divided by sigma P naught Q1. In the case of time reversal test, what we did was we had changed 0 to 1 and 1 to 0. This was in the case of time reversal test. But now, in the case of factor reversal test, we will change P to Q and Q to P. Therefore, changing P to Q and Q to P, we know that P is replaced by Q and the times remain the same, 0 and 1 remain the same. So P01 will be Q01. It is equal to sigma. Here it is P1 Q0. This will become P is replaced by Q, Q1 and Q is replaced by P, P0. So P1 Q0 will become sigma Q1 P0 divided by P0 Q0. This P is replaced by Q, Q is replaced by P, therefore it will become Q0 P0 into sigma P1 Q1 will be sigma Q1 P1 divided by sigma P0 Q1, it will be sigma Q0 P1. P0 P becomes Q, Q becomes P. Let us rewrite this formula as Q01 is equal to Q1 P0 is nothing but P0 Q1 divided by Q0 P0 is P0 Q0 into Q1 P1 is equal to P1 Q1 and Q0 P1 is equal to P1 Q0. The objective of why we are rewriting this is to further simplification, to simplify our calculation. The objective is to simplify the calculation. Now let us multiply the product of price and quantity so that we will arrive at the value. P01 into Q01. P01 values are here. We will bring down these same values of P01 as it is, P01 and Q01 which is given here. So after writing down all these common values, what remains here? Let's check out what remains here. Sigma P1 Q0 gets cancelled and sigma P0 Q1 gets cancelled. Now, after cancelling everything, we are left with P01 into Q01 is equal to sigma P1 Q1 divided by P0 Q0 again into sigma P1 Q1 divided by sigma P0 Q0. That is equal to sigma P1 Q1 divided by the whole square divided by sigma P0 Q0 the whole square. The whole square and the square roots gets cancelled, and finally we are left with P01 into Q01 is equal to sigma P1 Q1 divided by sigma P0 Q0. Since P01 into Q01 is equal to sigma P1 Q1 divided by sigma P0 Q0, Fischer's ideal index number satisfies the factor reversal test. Therefore, Fischer's ideal index number satisfies both the time reversal test and factor reversal test. So this is called as test of adequacy. This is also known as test of adequacy of index numbers, and for 15 marks question generally we are asked to check whether Fischer's ideal index number satisfies the time reversal test and factor reversal test. So I hope you all have understood the entire theoretical aspect of what is time reversal test and factor reversal test. In the next session, that is session number 26, we shall solve problems on time reversal test, factor reversal test and Fischer's index numbers. Session number 26, problems on index numbers. So we have problems on Fischer's index method, and we also are going to verify whether Fischer's index number satisfies the time reversal test and factor reversal test. So problem 1 says construct Fischer's index for the following data and verify whether it satisfies the time reversal test and factor reversal test. We've been given the details of the commodities. We have 5 commodities here, A, B, C, D and E, totally 5 commodities. We've been given the base year details and current year details with respect to price and quantity. Base year is always indicated by 0 and current year is indicated by 1. Therefore, prices of the base year will be P0, quantity of the base year is Q0 and prices of the current year is P1 and quantities of the current year is Q1. So this is the information given. Let us find out our Fischer's index numbers. So I have taken down the values here as price of the base year, quantity of the base year, price of the current year and quantities of the current year. And we know that the Fischer's index number is calculated as follows. The formula for calculating Fischer's index number is P01 is equal to sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1 into 100. Now from this formula we need to calculate number 1 P1 Q0, second P0 Q0, third P1 Q1 and fourth P0 Q1. The order need not be the same, the order can change. So now what is P1 Q0? That is price of the current year multiplied with quantities of the base year. P1 into Q0, 20 into 100, 2000, 4 into 200, 800, 12 into 120,000, 440, 24 into 60, 1440, 24 into 80,000, 920. And when we add all the values of P1 Q0, we get the total, which is sigma P1 Q0 is equal to 7,600. I'm sure by now, by watching the previous videos, you all are sure of how to calculate P1 Q0. So similarly, I have calculated all the values of P0 Q0, P1 Q1, P0 Q1, multiplying the price of the base year with the quantities of the current year. Here we are multiplying the prices and quantities of both the current years. Here we will multiply the price and quantities of both base years. So after obtaining all the required values, P1 Q0 is equal to 7600 divided by P0 Q0 is equal to 5440 into P1 Q1 is 7040, P0 Q1 is 5056. All these values have been obtained in the table here. We are just substituting the respective values in the formula into 100, which is equal to square root of 1.3970 into 1.3924 multiplied by 100. So finally what we get is P01 is equal to 139.46. Therefore this is the Fischer's ideal number, which is 139.46. So this is how we calculate Fischer's index numbers, which we have already done in our previous session. So there are three things in this question. Number one, they're asking to construct Fischer's index number. Second, they're asking us to verify whether it satisfies time reversal test, which is the second. And third, we have to find out whether it satisfies the factor reversal test. So till this stage, we have completed the first part, which is constructing the Fischer's ideal index number. So next, let us proceed and find out whether it satisfies the time reversal test. Well, we know that time reversal test is satisfied when P01 into P10 is equal to 1. We know the value of P01, but we don't know the value of P10. Therefore, we have to find out what is P10. So P10 is nothing but changing time from 0 to 1 and 1 to 0, and we get our formula of P10, and we know what is P01 and into P10 is equal to, right? Then now let us substitute the values in this particular formula. P1 Q0 is 7600 divided by 5440 into P1 Q1 is 7040 divided by P0 Q1 is 5056 multiplied by P0 Q1 is 5056, P1 Q1 is 7040, P0 Q0 here it is 5440, and P1 Q0 is 7600. Further, when we observe here, numerator denominator gets cancelled. 70 40 70 40, 50 56, 5440 5440 gets cancelled, and what is finally left is only 1. Therefore, P01 into P10 is equal to square root of 1, which is nothing but 1. Since P01 into P10 is equal to 1, we can state that Fischer's ideal index number satisfies the time reversal test. So this was this second part of our question that asked us whether Fischer's ideal index number satisfies the time reversal test. So we can say that yes, Fischer's ideal index number satisfies the time reversal test. Next, we are left with the next part of the question, which says whether Fischer's index number also satisfies the factor reversal test. Factor reversal test is satisfied only if P01 into Q01 is equal to sigma P1 Q1 divided by sigma P0 Q1. In our previous session number 25, we have understood what is P01 into Q01 is equal to. So straight away I'll go to this part. P01 into Q01 is equal to the following formula. So for the respective formulas, let us substitute the values. P01 into Q01 is equal to what? I think there is a step which has been missed here. So let us do that step and then come back to this. Well, what is sigma P1 Q0? Sigma P1 Q0 is 7600 divided by sigma P0 Q0 is 5440 multiplied by sigma P1 Q1, which is 7040 divided by sigma P0 Q1, which is 5056 into sigma P0 Q1, which is 5056 divided by sigma P0 Q0, which is 5440 into sigma P1 Q1. Sigma P1 Q1 is equal to 7040 divided by sigma P1 Q0, which is 7600. Now, after finding out all these, let us find out what gets cancelled. 5056 in the numerator, 5056 in the denominator gets cancelled. Similarly, 7600 in the numerator, 7600 in the denominator gets cancelled. Therefore, P01 into Q01 is equal to square root of 7040 divided by 5440 into 7040 divided by 5440. P01 into Q01 is equal to square root of 7040 the whole square divided by 5440 the whole square. Therefore, P01 into Q01 is equal to 7040 divided by 5000 divided by 5440. That is, P01 into Q01 should be equal to, according to our Fisher's ideal index number statement, P01 into Q01 should be equal to sigma P1 Q1 divided by sigma P0 Q1. That is, sigma P1 Q1 divided by sigma P0 Q1. And we know that sigma P1 Q1 is equal to 7040 and sigma P0 Q1 is equal to 5440. Therefore, from the above formula, we can clearly state that the Fisher's index number also satisfies the factor reversal test, which is part number 3. Therefore, we can state that Fisher's ideal index number also satisfies the factor reversal test. So this is how we solved problems for 15 marks, where they generally ask us to calculate the Fisher's index number and also verify whether it satisfies the time reversal test and factor reversal test. So with these two videos, I hope you all have been able to understand what is time reversal test, what is factor reversal test, and how do we check whether the Fisher's ideal index number satisfies both time reversal test and factor reversal test. Thank you all.